So I think we are recording this, and so we're going to do all kinds of fun stuff. So there we go. Okay. Earlier this morning, my lights in my office kept going out, so I kept having to wave my hands around. So if I do that, I'm not crazy. I'm just trying to keep my lights on, so it was a little bit strange. All right, so once again, just a reminder for those of you who kind of came in a few minutes after we started talking, the homework and quiz number 1, or the homework and quiz for chapter R, these are labeled by chapters, is due tomorrow at 11:59 p.m. Keep in mind that you can keep working on the homework until you get 100 on it, and then make sure you use your notes and everything to take your quiz. One of the things that I was talking about as we were getting started was that I didn't mention to the other day is that for every test, there is what we call a mastery quiz or a test review. And it's like a quiz in that it is timed, and it looks more like a test than a homework assignment. You have to work the whole thing and submit it to get a grade on it. But it is the quiz that you are going to get 3 attempts on. So I will, and we'll talk a little bit more about that when we get closer to the first test. The first test is next Monday. It's on Monday the 8th. And so on Friday, we'll talk a little bit more about that, the mastery quiz and the test and everything. But just know that you can take it 3 times. Only the best grade counts. And it's a great opportunity to practice and review before your test. So I know it's a little bit daunting that you can do multiple attempts on homework, but then only 1 attempt on the quiz. But that mastery quiz does afford you a couple of chances on it. So, okay. All right. So yesterday I didn't get much input at all. So today I may have to call on people, or I may stop you and say, okay, somebody's got to answer my question. If you don't want to chat out loud, that's fine. Remember, if you do answer me, you need to unmute your microphone so that I can hear you. And okay, I've got somebody trying to join, so I'm going to send. And okay, so guys, you may get an email from me if you have your email running. That's going to tell you to join the session, but it's really not meant for you, so just ignore that. It's because I've got somebody trying to join that can't join. So hang on. This is I can't think and talk and type at the same time. Okay, let's see if that helps this person. Okay. All right. Sorry about that. I don't multitask well. I think it's an age thing, so bear with me. Okay. So, but I do want you to ask questions. So if you've got questions, type them in the chat or answer or ask them out loud. Pause me, stop me. I do want this to be interactive. I get tired of listening to myself talk after a while, so I can only do that for so long. Okay, so we're going to jump on into chapter 1. We're just doing the first section 1.1 and 1.3. We don't do 1.2, so we kind of jump around a little bit in this. But really the purpose of this course is to get you ready to take college algebra. And so we try to hit some of the things that we think you've forgotten maybe over the past couple of years, or just haven't used that much, and try to hit some of those high points so that when you hit the ground running in college algebra next semester, you will be good to go and be super successful in that class. So we're going to jump on into this chapter, and we're going to talk about solving equations. So the first types of equations we're going to be talking about are what we call linear equations. So a linear equation, does anybody know what the graph of a linear equation might look like? Think of the word linear. What do you think the graph, if I were to graph a linear equation, what do you think it might look like? I'm going to start calling on people. Let's see.
It would be straight across.
Yep, it's going to be a straight across. It's going to be a line. Okay, so a linear equation is going to be the graph of a line. And so for that reason, it has this really super nice relationship. And so what happens is, because it has that really nice relationship, then it's going to have an x to the first power. So a couple of things that make a linear equation special are, one, it has just one variable. So x is our variable. This a and b are going to be numbers. And the second thing is it's an x to the first power. So the power up here is an understood 1. So that's what makes something a linear equation. So if you look at a whole bunch of equations, let's say if I gave you the equation y is equal to x cubed plus 5. Maybe I gave you the equation 2y plus x is equal to 7. I know we've got x's and y's in here. It's okay. Let's say I gave you y is equal to x squared minus 3. Okay, so equations 1, 2, and 3. Tell me in the chat which one of these is a linear equation. Type into the chat and tell me which is the linear equation. One, 2, or 3. All you got to do is type in a 1, 2, or a 3. Nobody's chatting. There we go. Excellent. Very good. Excellent. Very good. Somebody was waiting for somebody else to be first. You can't do that all the time. Okay, so 2 is our linear equation. And guys, this is really important that you recognize because sometimes we solve them in different ways. And so right now we're just going to be talking about solving linear equations, okay? And so when we do that, we want to make sure it's balanced. I don't know whether, so this is going to tell you just how stinking old I am. But anyway, when I was little, we had things called seesaws. And you may or not have ever played on a seesaw. I don't know whether they even still have those. But a seesaw is like, it's a balance thing. So it's like a bar and you have this thing in the middle and somebody sits on either end and you balance it out. And so the idea was if you put 2 people on one end, you had to put 2 people on the other end so that it balanced out because otherwise bad things happen. So what happens in an equation is we want to keep it balanced. So the idea is that we do the same thing to both sides. So if I have this expression where a plus something is equal to b plus something, and I subtract that same thing from both sides, then I can find out something else about my equation. So as long as I add the same thing to both sides, subtract the same thing to both sides, divide the same thing into both sides, or multiply both sides by the same thing, life is amazing. And I still have an equation that's where one side is equal to the other. Okay, so enough with the words. I know there's too many words on this screen, so let's get into some problems. So when we solve linear equations, I know, another wordy page, I'm sorry, we need to get rid of fractions. Most of you guys don't like fractions. I personally prefer fractions over decimals. I don't know why, I just do. So you're gonna hear me say that 1,000 times, okay? But we're gonna get rid of the fractions and we're gonna do that by multiplying by a common denominator. We're gonna simplify the terms on either side of the equal sign. So we're gonna simplify the left side, simplify the right side. And then we're going to isolate the variable. And we're gonna do that by doing the same thing to both sides of the equation. What you do to one side, you must do to the other side. Big stars, big stars, big stars, okay? And then we're gonna find the value of the variable, right? So if you wanna go back and kind of look at this process, sometimes that's what these printed out notes are for. So backtrack real quick. I hope that everybody sitting out there listening to me has their printed out notes in front of them and that you have these to write down. Some people tell me they're like, I like to write the problems down. Print out the problems because sometimes there's more than just problems. Sometimes there's instructions, sometimes there's helpful hints, and then you can work the problems by writing down the problems. But I think it's good for you to have these notes in front of you. I just think it's helpful. So anyway, okay, somebody else has joined us because I got more people in here than I did to begin with. So I'm going to look and see who else is here. Hannah, you made it. I see you. That makes me happy. That means you got my invite. Chelsea, did you make it? Let's see. We have, yes, Chelsea, you did make it. And hopefully you can see my screen. And, okay, I've still got one more that I'm missing, but I don't know where she is. Okay, 2 more that we're missing. Okay, anyway, all right. So if you've come in, just make sure that we talk at the end. So, okay, perfect. Thanks, Chelsea. I appreciate that. Okay, so we're going to solve this equation. So the very first thing I want you to do is I want you to look at the left side that says 2x minus 5. The right side says 7 plus 6x. This is a linear equation because I'm x to the first power. There is nothing I can collect together on the left side. 2x and minus 5, can't do anything with them. 7 plus 6x, can't do anything with them. So the first thing I look for is to try to simplify, but I can't simplify. So you simplify before you solve, and there's nothing to simplify. So I'm going to solve this. Okay, question, backtrack. I want you to think about something. If I ask you to read this statement that I'm pointing to up here out loud, you would start with the word solve, correct? So solve each equation. You wouldn't read equation each solve, all right? So that would be silly. So why in the world do we want to put our x's on anything other than the left-hand side? I don't know. So my point being is unless we absolutely have to, keep your x's, your variables, on the left-hand side, okay? So when you solve an equation, try to keep the variable on the left. Variable on the left. Okay, I just think it's so much easier. All right, I don't care what else happens. Every once in a while we run into something else, but we're going to try to keep the variable on the left. Okay, so to do that, what I want to do is I want to move this 5. I need the x over here on the left. So to move the 5, I'm going to do the opposite operation. The operation here is subtraction, and the opposite, so we have pairs of operations. We have addition and subtraction, which are opposites, and we have multiplication and division, which are opposites. So we're going to do the opposite operation. So we're going to add 5 to both sides of this equation. Now, I only want to add the 5 to the like term. 6x is not a like term, okay? So I'm going to add 5 to both sides. So on the left-hand side, that leaves me with a 2x. On the right-hand side, that leaves me with a 12 plus a 6x. The next thing I need to do is I need to move my x's over here to the left-hand side because I have an x over here on the right-hand side. So to do that, I'm going to subtract 6x from both sides. So same thing, I'm only going to do this to like terms. And so on the right-hand side, I'm just left with my 12. And on the left-hand side, I have negative 4. And so now what I have is I have negative 4x is equal to 12, right? So I still need to get x by itself. Negative 4 is attached to x by the operation multiplication. And so in order to get x by itself, I have to do the opposite operation. Well, the opposite operation for multiplication is division. So I'm going to divide both sides by negative 4, and that's going to leave me with an x is equal to negative 3. And so my final answer is x is equal to negative 3. Now, I'm going to tell you right now that you should not miss these because you're lazy, all right? Now, what do I mean by that? It means you can check these. So if you get an answer for x, you can check them. So you take that x value and you plug it back into that original equation. So I'm going to show you how to check this. And I suggest, now this is like a mathematical phenomenon. I don't understand it. If you check it on the page with your work, sometimes you don't find your mistake. Sometimes you find it. Sometimes you don't. So I would flip the page over. I would check it on the back. I would find a receipt stuck in your pocket and check it on the receipt. A piece of scrap paper that's laying around on the table, check it. Just don't check it on the paper itself. I don't know why that is. It's a weird thing. So, but it's okay. So I'm going to show you how to check this one. So we're going to check over here. We're going to check x is equal to negative 3. And so we're going to go to the equation 2x minus 5 is equal to 7 plus 6 times x. And I'm going to put that negative 3 in. So I have 2 times negative 3 minus 5. I'm going to work just with the left-hand side. So I have negative 6 minus 5. And that gives me negative 11. Now I'm going to work with the right-hand side. So I have 7 plus 3 times 6 times negative 3. And I have 7 And then 6 times negative 3 is plus negative 18. And 7 plus negative 18 is indeed 11. And as long as the left side and the right side are the same, then it checks, and x is equal to negative 3 is my solution. You can check every single one of these, okay? So I'm not going to do it on all of these, but I highly recommend that you do. The homework has this great feature called check answer. Check answer is amazing. The quiz doesn't have check answer, okay? So make sure that you know how to check your answer. Okay? All right. So problem number 2 is different than problem number 1 because problem number 2 we have to simplify first. Okay? So the first thing we have to do is we have to simplify. So couple of the homework problems in the first chapter had to do with just simplifying expressions. And the reason that we do that is so that we can solve equations, because if you can't simplify correctly, you're going to have a really hard time solving these things. So I'm going to give you about 15 seconds to simplify the left-hand side of this equation. You can't do anything to the right-hand side, but simplify the left-hand side. Write it on your paper. I'm going to be quiet for a total of like 20 seconds. Okay, my 20 seconds is way past up. Sydney, I see you joined us. Can you hear me? Maybe? Okay, I see you. I see that you're here. Okay, we'll talk later. Okay, so simplifying this, hopefully you got 2x minus 10, and you didn't forget to take the 2 to the 5, and then plus 3x, and this is equal to x plus 6. I'm not done simplifying because I still have some terms I can collect together on the left-hand side. So 2x plus 3x is going to give me 5x minus 10 is equal to x plus 6. All right, so now it's simplified. There's nothing else I can do to simplify. So once I've simplified, at this point, I want to solve. So when we solve, we're going to do those opposite operations. So the first thing I'm going to do is I'm going to move the 10. Since it's subtracted, I'm going to add 10 to both sides. Notice I'm adding the 10 on the right-hand side to the 6 because those are my like terms. And so on the right-hand side, I have x plus 16. And on the left-hand side, I have a 5x. Okay, so I have a 5x over here. So I have 5x is equal to x plus 16. So now I'm going to do the opposite operation here, and I'm going to subtract x from both sides, making sure that when you move across that equal sign, you change that sign. That's what you're doing. And so I have 4x is equal to 16. And now I can do the opposite operation here, which is I divide both sides by 4. And so that's going to give me a final answer of x is equal to 4. And you can check that if you want to by plugging it back in. In this case, you have 3 x's to plug it into. Simplify left side, simplify right side. And you should get the left and right side in this case are both equal to 10. Questions? We good? All right. More simplify. Okay. So this problem, we've got simplification on the left side and simplification on the right side. Okay. So let's go through, and on the left-hand side, I see a 4x and a 1x. And so this is going to give me a total of 5x plus 8. And on the right-hand side, I have 3 minus 10. So I'm going to have a negative 7 plus 5x. Okay? So, what do I want to do at this point? Somebody either type me in an answer or give me an answer? What's the first thing I want to do at this point? I'm going to do something with 8. Somebody tell me what I want to do with 8.
Subtract the 8 on both sides.
Excellent. So I'm going to subtract the 8 from both sides. Very good. Thank you very much. Okay, so that's going to leave me with a 5x over here. And it's going to leave me with a negative 15 plus 5x over here. Now this next one's going to be a little bit strange. Excellent. So okay, so somebody said subtract it. Are you meaning the 5x I'm going to subtract, or am I subtracting the 8? Help me out.
I'm at the 8.
Okay, either way is fine. So what am I going to do to this one? What's the next thing I'm going to do? Huh? I need to move my x. So how am I going to move my x? What's the operation that's opposite of subtract? I mean, of addition.
Add it.
Okay. Well, I added it over here. So to get it to the other side, what do I want to do?
Subtract it.
Subtract. Okay, I see the little minus sign down there in the chat. Okay, that's not helpful. I can't see that. That's too little. Okay, so on the right-hand side, I have a negative 15. What's 5x minus 5x? Don't everybody answer at once. It's 0. Yes. It's
0. I got mine on mute. My fault.
It's okay. You're good. So, but you've got actually a good idea there. So it's fine. So this is actually, and I'm actually glad somebody put the wrong answer in here. So we've got a couple of things because we are fixing to have a problem. We've got several things going on here. Don't be surprised if I subtract everything and it disappears. So I get 0 over here. But Brandon, you raised an interesting point here. You said undefined, and I'm not sure whether you were thinking about the 5 minus 5 or the 0 is equal to negative 15. But you're right in that I can't have 0 equal to negative 15. That's not possible, okay? So for this particular problem, we simply say that there is no solution. And you know what? In the real world, we sometimes run across things that there is absolutely no way we can solve it. It could be relationship issues. It could be the fact that I couldn't get out of something. But, sometimes we have no solution. So when we talk about math problems, sometimes we have no solution. And, if you end up with a statement and you're like, that's not right, I can't do that, then you simply say, I have no solution. So I got rid of the variables and I had this really funky statement, okay? So we can have no solution.
Miss Walters, so if I put undefined, you won't take that either?
I will not take that because, and here's the catch. So this is the nice thing, Brandon, is that if you were answering this question, it would be probably a pull down menu. So in MyLabs Plus, it would have like a little arrow and you could pull it down. And one of the options would be no solution. So you wouldn't have an option to type in that undefined. Now, if it was one where you were typing in an answer, like on a test or something, and that's actually a good point that you bring up, because if you put something in the wrong form, but it's really the right answer, if you ask me, I'll look at it and I'll probably give you credit for it. So just know that going forward. So if it said to put the answer for the solution and you put x is equal to 2 and it just wanted you to put 2, please let me know that because I can definitely go back and give you credit for that. Okay. So sometimes though you might see this little symbol and that actually means the empty set. So that's the same thing as no solution. Okay. Does that make sense?
Yes,
okay.
It does.
So be careful there. Okay. All right. All right. Number 4 down here is a little bit messier. And so we've got to do lots of simplifications on this one. So we're going to start by simplifying and distributing this 2. So we have 2x plus 4. Don't forget to take that 2 to both pieces. On the right-hand side, I've got a 5x and a 2x, and so I'm going to simplify that to give me 3x, and I have a 3 and a 1, and that's going to simplify together to give me 4. Okay? And so now I can go about solving this, and we're starting to get an idea. You might not like this one either, but it's going to be okay. So I'm going to subtract 4 from both sides, right? And that's going to leave me on the left-hand side with 2x and on the right-hand side with 3x. Now, here's where we have to be careful because I don't have any constants here. I don't have any numbers that are left, but I still have to solve for x. And so what I need to do is I still need to subtract 3x from both sides. So pay real close attention to what's going to happen here. I'm going to subtract 3x from both sides. And on the left-hand side, I'm going to get negative 1x. And on the right-hand side, I'm going to get 0. And if negative x is equal to 0, then that means x has to be equal to 0. Be careful because this is not the same thing as no solution. It just simply means the only number that makes this statement true is if x is equal to 0. All right? So there's a reason that both of these problems are on the same slide so that you can see them together. Sometimes we think of 0 as being nothing, but 0 is actually a number, right? So, I mean, it's kind of an important number. And so sometimes you get a solution where the value is just 0, and then sometimes you get something which has no solution. So there is a difference there, okay? Right? Okay. Questions, let me know. Okay. So let's move along. Okay. So this one has our friends, the fractions, in it. I know, some of y'all don't like fractions. I told you fractions are our friends, but we're going to get rid of them. I promised you we would get rid of them. So what we need to do is if we see fractions in a problem, okay, and you don't have to, you can work it with the fractions, but I'm going to show you how to clear out the fractions. So what we're going to do to clear out the fractions is we're going to find what's called our least common denominator. So to find our least common denominator, we're going to look at the denominators that are here. And our least common denominator is really our least common multiple of the denominators. So there's several different ways to go about doing this, and I'm going to tell you what I think is the easiest way to do this. The largest number in the denominator is 5, okay? So we're going to start with 5. Does 4 divide into 5? The answer is no, it doesn't. So start looking at multiples of 5. So 5. And then I go to 10. 4 doesn't divide into 10. The next one is 15. 4 doesn't divide into 15. The next multiple of 10 is 20. Does 4 divide into 20? And the answer is yes. So 20 is my least common denominator. Now, somebody is probably sitting there going, can't I just multiply 4 times 5? You can. And quite often that will give you your least common denominator. But look at number 6. I have 3 of them. I don't want to multiply all 3 of those numbers together. And so we're going to use the same technique on number 6 that we used on number 5 up here. But sometimes if you just have 2 denominators, you can multiply those together. Now, when I work this problem, I'm going to go through kind of a long process to do this. So if you can skip steps, that's fine. I don't have a problem with that. But if you start making mistakes, go back and try to fill in some of these steps. Because once again, these are the things that you're going to need in order to be successful in algebra. So what we're going to do here, and I'm just going to rewrite this problem. So I have x over 5 and minus x over 4 is equal to 1. And so when I do this, I'm just rewriting this so you can see what I'm about to do. I'm going to multiply every term up here by my least common denominator of 20 over 1. So that is my fraction form. And so I'm going to multiply it by, now notice over here, when I have multiplied by 1, I don't multiply by 20 over 1. When I do this, if I've done this correctly, Then 5 will divide into 20. And when 5 divides into 20, it's going to leave me with a 4. And so now I'm going to have 4x left here. The next part, 4 divides into 20, and it leaves me with 5. And so I have a minus 5x. And then 1 times 20 is going to be 20. And now I have that very nice linear equation that does not have any fractions in it, okay? Don't forget to multiply it by the 1 over here on the right-hand side, or the whole thing just blows up, okay? So multiply each piece by your least common denominator, and now we can simplify it. Now we can simplify the left-hand side. The left-hand side is going to simplify to negative x. The right-hand side, there's nothing to do with it. So I'm going to move this over here so we can see. So I have negative x is equal to 20. I'm going to divide both sides by negative 1. And when I divide this left-hand side, I get a positive x is equal to a negative 20. And negative 20 is my solution. Okay? And it's just an accident that it's the opposite of this number. It's not always going to be that. So before somebody gets some great smart idea and says, I'm just going to change the sign, you're not going to be right. Just saying. I know some of y'all out there. All right, questions. Questions. Okay, so let's look at number 6, and then I'm going to make you try to work number 6, or at least get it to a point before I try to do it with you. So the first thing though I want to do is I want us to find that least common denominator. So the least common denominator for number 6, I'm going to do the same thing I did with number 5. I'm going to look at these 3 numbers, and I'm going to start with the biggest one, 6. 2 divides into 6. Does 4 divide into 6? No, it does not. Next multiple of 6 is 12. Does 2 divide into 12? Yes. Does 4 divide into 12? Yes. Least common denominator is 12. Okay? Multiply each term by 12. I'm going to give you about 60 seconds and see what you come up with. So work diligently. I'm trying to make sure I got all of you guys present over here. Excellent. Okay, so here's what I want you to do. I'm going to work it, and I'm going to multiply each of these things by 12. I'm actually going to do it like this. I'm going to put my 12 here. I'm just going to kind of put this in this part. And then we're going to look and see if you have exactly the same thing that I do. So hopefully you got to that point. Here's where I want you to be really careful. Don't forget to do it times the 2. You've got to do this times every single piece, okay? So now, when I divide 4 into 12, I'm left with 3. So I want to multiply this 3 times the 3x, and so that's going to give me 9x, okay? Notice that this one has an x on it. It's out beside it, but you can think of it as in the numerator. It's exactly the same thing here beside it or in the numerator. Either one is the same. 2 is going to divide into my 12. So I'm going to have plus 6 here. 6 is going to divide into my 12. So I have a 2 times that 5x. And so this is going to be equal to a 10x. and then 2 times 12 is going to be 24. I'm going to stop here. Does anybody have any questions as to how I got to this point? Because this is like big. So if you did not get exactly this, I need to know now. You can send me a private chat. You can raise a hand. You can wave a flag. Okay, I'm going to presume we're all in the same place now. Okay, so again, I'm going to solve it. So I've simplified. This is part of that simplification process. So I'm going to subtract 6 from both sides. And so that's going to leave me on the left-hand side with my 9x is equal to 10x. And I have 24 minus 6 because I'm doing that opposite operation there. And so 24 minus 6 is going to be a plus 18. Yes. See, sometimes I just don't do arithmetic well, so my head hurts. Okay, and so now I'm going to subtract 10x from both sides. And you can do several steps at once if you want to. That's perfectly fine. So negative x is equal to 18. And now in order to solve this, I can multiply both sides by negative 1, or I can divide both sides by negative 1, however you want to think about that. Some people are just like, can I not just change the sign on it? Sure, you can just change the sign on the 18 to the negative 18. And then that is my final answer. Questions? And you know how to check, right? Because you can go back and plug that negative 18 into all of your x's and make sure you get the same thing on both sides. I know, even with those fractions, terrible, horrible things. It's amazing what your calculator will do. All right. We doing okie doke? Okay. More fractions. Fractions are our friends. Okay, I'm going to be quiet for a minute, and somebody is going to tell me either in the chat or out loud what the least common denominator for this problem is. Say that again.
15.
15. Excellent. Thank you very much. That was you, Bill, yes? I think so. Okay.
Yes.
See, I got this. I'm getting this. Okay. I can cheat because I can see everybody's name up here. So I just have to remember who's who. All right. So sometimes I just can't tell who's talking. So I'm going to multiply everything by 15. Now I'm going to write this a little different this time. So I'm going to actually multiply this 15 times each piece. And I think sometimes when they get a little bit messier like this, it's much easier if we go through and we actually do this. And we just multiply it in the numerator here. And then I have 2 times 15 here. So I know sometimes it looks a little bit different. So if I'm confusing you by that, just make sure you ask me. You can either send me an email or, thank you, Cody, I see that also. So you can either drop me an email or you can send me a picture of it and say, hey, I still don't get this. It's okay. We'll figure it out. So here, like I said, I like to write it like this because I think it really kind of helps you see what's going on. So the 3 divides into the 15 and leaves me with 5. And so I'm going to have 5 times, and I'm going to take this extra step in here, times x plus 3, okay? And then plus, in this next term, my 15 divides out completely. And so I have plus, and I have x minus 3. Now notice I'm leaving this in parentheses. You don't have to if this is a plus sign, but if this is a minus sign and you forget the parentheses, you are so going to be toast. So don't do that. So just put it in parentheses. It's not going to hurt anything. We're going to get rid of it in a second. So then 2 times 15 is 30. Okay. All right. So now I'm going to simplify. So I've simplified by getting rid of the fractions, but now I'm going to simplify further. And so now I'm going to distribute my 5, and I'm going to drop my parentheses. And so on the left-hand side, I have 5x plus 15. Don't forget to multiply it times both pieces. And then plus x minus 3. This was a negative. We would be distributing that. It's not, so it's well, we can just drop that. One more step to simplify. So this is going to be 6x, and then plus 12 is equal to 30. Now in this case, I have 6x plus 12 is equal to 30, and so now I've simplified everything. I only have x's on one side, so that's not so bad. So now I'm going to subtract 12 from both sides. And when I subtract 12 from both sides, I get 6x still over here on the left-hand side. And on the right-hand side, I get 18. And now I can divide both sides by 6. And as I divide both sides by positive 6, I get that x is going to have a value of, and that's going to be lovely. And that's going to be my x value. That was so much fun. I love these problems. Some of my favorites. My favorite friends are fractions. Yay! All right.
So I have a question.
Excellent.
If we want to say just practice, like not the homework, but just practice just random questions, is there a place we can do that?
Oh, yes, there is.
Okay, where? I need it.
So if you look in My Labs Plus, there's a couple of things, and I think this is amazing because there's a couple of things, and I'm really actually glad you asked this because sometimes I forget to tell students this. My Labs Plus automatically generates for you a study plan. When you take your first quiz, it'll generate some practice problems that are based on what you miss on that. But you can actually go in and you can work any problems. When we get to the end of class today, I'll jump onto My Labs Plus and I'll show y'all how to get to like the textbook and the extra problems and stuff like that. So if you'll help me remember to do that at the end,
Okay.
I'll show y'all where to find that. It doesn't affect your grade at all, and there's some really good problems in there just to practice with. So yeah, and you can also actually another thing you can do is once you get 100 on the homework, you can actually go through the grade book, and I'll show y'all this too. And you can click review in the grade book, and you can rework every single homework problem, and it doesn't change your grade. So if you missed one because it was just one of these really nasty problems that you finally got right and you thought, I don't want to do that one again, but you could actually rework it, and even if you can't get it right the second time, it's still not going to change your grade. Okay?
Okay.
And so that's kind of
Right.
nice. So remind me at the end, and I'll definitely pull up My Labs Plus and show y'all how to do those things. So, yep, perfect.
Okay, thank you.
Yep, no, thank you. I forget sometimes, so you'll have to remind me of crazy things. Okay, so let's look at this one. And so again, we're going to have that really nice same denominator. Is that the same problem? No, it's not the same problem. Okay, I was like, that looks like the same problem. We're going to have the same denominator though, and I think that's why I put this one in here, so we can use the same denominator. So my least common denominator is still going to be 15. So again, I'm going to multiply everything up here by this 15. And so this is going to give me 15. And then I have times my x plus 3 over 3. And then I have minus, and again, I'm going to have 15 times my 5x minus 15 over 15. And I'm going to have 2 times my common denominator of 15. Okay. So same thing I did a while ago, but we're going to have a little bit different outcome here. So I'm going to divide this in. I'm going to get 5. So I have 5 times my x plus 3. I really do have a method to my madnesses sometimes. Y'all think I'm crazy, but it's okay. And then minus, and my 15 divides in. Now watch this. If you don't put parentheses here, you are so going to be in trouble. So don't forget your parentheses. Okay. And then over here on the right-hand side, I'm going to get 30. Why did I worry about the parentheses? Because at this point, I need to simplify the left-hand side. So I have 5x plus 15. Because I have this minus sign here, I have to change the sign on everything in this parentheses. Please be careful, This is going to become minus 5x. That's not the problem. This is going to become plus 15. That would be a problem if you don't do this correctly. So this is like having a negative 1 out here in front, and we're distributing that. So you're essentially changing the sign on everything on the parentheses. And then over here on the right-hand side, I have my 30. Okay. So now when I simplify, something weird is going to happen here, and it's not because I made a mistake. So this problem had a couple of things. One, it has the minus sign, and two, it has the something strange happens here. My 5x minus 5x, that goes away. And so when I simplify this left-hand side, I just have 30. And 30 is equal to 30. Huh. You know, a while ago, Brandon, you talked about the undefined case. Well, this is kind of the opposite of that. This is always defined, I guess you could say. So if you have a statement at the end and you got rid of all of your variables and you just had two numbers that were equal to each other, and those two numbers were really equal to each other. Okay, a while ago we had like 0 was equal to negative 11, and that wasn't ever true. But 30 is always equal to 30. So sometimes rather than having no solution, we have infinite solutions. And so this is a case where I have infinitely many solutions. And so that's kind of what I would say. And this would be, again, this would be like a pull down menu, or it would be like a multiple choice. And you would say, oh, no, there's lots of solutions here. And so you would just mark that as the answer. So basically what that means is that everybody in class could pick a different value of X, and it would still be a true statement. So it's going to be true no matter what my value is. Okay. So just kind of keep that in mind, that this is possible. So if all of my variables disappear and I have a true statement, I would say I have infinite solutions. Okay. All right. So that's kind of a little bit of a strange thing that happens, but it does happen sometimes. All right. Okay. So we're going to talk about some applications. Now, I know this is probably everybody's least favorite part of algebra, but it's probably my favorite part of algebra, because it's the answer to the question of, and I taught middle school for a little while, and my students were always like, oh, when am I ever going to use this? And I'd be like, here we go. We're going to use it right here in these application problems. Sometimes they're known as word problems. So, and everybody's got their mics muted, so I can't hear your audible sigh of arg. It's okay. I hear that enough in class. So we're going to talk about solving application problems or word problems, or when am I ever going to use those problems. And okay, so maybe you don't care when the boat's going to hit the train, but that's another story. So we'll do those for another day. So when you solve application problems, you got to do several things. And going through this process is not mandatory, but it's helpful. Read the problem. I know that sounds really silly, but you read the problem, make sure you understand. Pick a value to assign, pick a variable to assign to what you don't know. Make an equation, solve the equation, figure out what the answer is, and then you can always check them. Okay? So we're going to try to go through this process for each one of these. This is going to be really helpful to have these examples when you do your homework, because guess what? I tried to pick examples that were very similar to your homework problems. You can say thank you later. Okay. So the length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110 centimeters. Find the length and the width of the rectangle. Okay, so the very first thing I'm going to do is I'm going to realize what I'm talking about here. I am talking about a rectangle. So I am going to draw a rectangle. And I have this really cool feature where I can draw a really pretty rectangle. Oh, look at my rectangle. That's so pretty. Y'all can't draw a pretty rectangle like I can. Okay. So there is my rectangle. So draw a picture. I read the problem. I see this word rectangle in here. I am going to draw a rectangle. Most of the time, and we're pretty consistent with this in math, the length is the longest side. And I think that's because length and long both start with that same letter L. Okay. So the length of my rectangle is going to be right here. So I'm going to call this L my length. That means this is my width. Now, it says find the length and the width. Okay, I'm going to let width be X. So now I've assigned a variable to my value that I'm missing. So I'm going to say x is equal to the width of the rectangle. Why did I pick x to go with the width? Because I know something about the length in terms of the width. Now here's what I need you to do for me. I need you to look at this statement that says the length is 1 centimeter more than twice the width. There are two operations involved in that. There is multiplication and addition. Okay? Twice the width is the multiplication. So the length is twice the width, 1 centimeter more plus 1. And here's what I need you to do. Always do the multiplication part first. Okay, did you hear me carefully? Always do the multiplication part first. So if it said 1 centimeter less than twice the width, we would do 2x minus 1. Always do the multiplication part first. It will keep you out of trouble. I don't like y'all to get into trouble with math, so I try to keep you out of trouble. Don't be hard-headed, and I got a couple of folks I think are hard-headed. Don't be hard-headed and say, I'll show her, because guess what? I'm going to be right. All right, because I'm more hard-headed than you are. So let's just do it my way. So put the multiplication part first and then the addition or subtraction. So now I have a pretty picture. The other thing we know about a rectangle is the opposite sides are the same. So this side has length x, and this side has length 2x plus 1. So I have 4 sides to my rectangle. Perimeter. Does anybody remember what perimeter means? I don't want a formula. I want to know what it means. It's a distance. Where is it?
The outside distance.
Exactly. It is the outside distance. That's a perfect way to define it. So the perimeter is what goes around the outside. The other thing I want you to notice is that this is centimeters, not centimeters squared, so I'm not multiplying everything. So perimeter is the sum of all of the sides. That's it. Perimeter is the length plus the width plus the length plus the width. If you happen to remember it's 2 times the length plus 2 times the width, go for it. That's a formula. It's lovely. You don't have to remember it. I don't care. Perimeter is 110. Length is 2x plus 1. Width is x. Length is 2x plus 1. Width is x. There's my equation. Perimeter we're given as a distance, is a measurement. Length we know is 2x plus 1. Width we know is x. There's another length and another width. And now you know what? You know how to solve an equation at this point because we simplify both sides. 110 we can't simplify. On this side I have 2x plus x plus 2x plus x. That looks like 6x plus 2. Now, because of the way we wrote this, our x's are on the right-hand side. Is that a problem? Absolutely not. Do I like my x on the left? Yeah. Is it essential? Nah, it's okay. So we can still solve it. If I had a preference, I'd probably put it on the left, but I didn't, so it's okay. So I solved this by subtracting 2 from both sides. And this gives me 108 is equal to 6x. I'm going to divide both sides by 6. And I hope this comes out to be a nice number. And so x is going to be equal to 18. It is a nice number. So now I have a question. What is x? Don't tell me 18. I can look at x and see that it's 18. But what is x? What does it represent?
Width.
It's the width, exactly. So when the problem says, and it's going to say the width is blank, and it's actually probably going to say the length is blank because they list length first. I'm going to put width right here. It is 18 centimeters. Huh. How do I find the length? kind of curious. How do I find link?
Do you double it and plus one?
Exactly. That's exactly what I do. I double it and add 1 because it says the length is 2 times the width plus 1. So 2 times the length is going to be 36 plus 1. And so I'm going to find that the length is 37 centimeters. Make sure you put these in the right place because they're going to be wrong otherwise. Okay? So you'll get 2 different blanks. Make sure you put them in the right place. Right? Can you check that? Sure. 37 plus 37 plus 18 plus 18 better be 110. So yeah, you can check this just like you did the other ones. Our first practical application problem. I love it. Okay. So this is actually, I found this problem and I thought, this is so relevant. Why don't we do some like real problems? So even though finding the length and the width is very important. So, but a hotel manage, that is not manage, manager. I can't type. A hotel manager found that his gross receipts for the day, including 5% sales tax, were $2,546.05. Find the amount of sales tax collected. How are we going to do that? Well, we're going to let X be the amount of taxes. Okay, that's what we're going to do. We're going to let X be what we're looking for. Okay, so now we need to kind of play with the numbers here. We know that the total, we're going to write a statement. The total is equal to the receipts, okay? So the amount plus the amount of taxes, okay? So this is the amount of receipts. We'll write it like this, the amount of receipts plus the amount of taxes. Okay, so we know that the total is $2,546.05. So we got to figure out something because we know that the amount of taxes is X, and so we've got to add this. Let's see what we need to do. I think I should have not done that, but that's okay. No, we're good. Okay, so my taxes are 5%. So let's write this over here. No, X is not going to be our amount of taxes. See, sometimes I have a brain cramp, and my brain just cramped. So X, sorry, this is what happens when I lose a typo. Okay, so sales tax, let's write this. Sales tax is 5% of the amount of receipts. Okay, all right. We're going to come back to that. Okay, so sales tax is going to be, that is not, what do I want to write next? So sales tax, the tax is 0.05 of the original amount. So we're going to let X be the amount, not the gross, but the amount of receipts. All right. And the reason we're doing this is because our sales tax is based on the original amount. So he's got this amount. So the total, the gross receipts, that's just what we need. The gross receipts is the amount plus the sales tax. Okay, so this is the original amount plus the sales tax is our gross. And so our gross income is $2546.05. And that's going to be equal to X plus 0.05 times X. Does anybody know why I changed this to 0.05? Anybody remember that? What do you do with percent to get it into a decimal? You have to divide it by something. Does anybody remember, would you divide percent by to get it into a decimal? What is percent out of? How many cents are in $1? There's 100. So to get a percent into a decimal, we divide it by 100. So that 5% we divide by 100 or move our decimal 2 places. All right, so now we have simplifying this problem, and this is where we're definitely going to want our calculator. What's the number in front of this x here? It's an understood number, and it's actually an understood 1. And so when I add x plus 0.05x, I get 1.05x. And that's part of why I wanted to work this problem with you guys, because I wanted you to see that 1 here. And so now, in order to solve this, I'm going to divide both sides by 1.05. And again, I'm going to really want to make sure that I have a calculator handy, because I am so not doing this on my own. So I'm going to pull out my calculator. So 25.36, divided by 1.05. And hopefully, ooh, we get a lovely number. I get 24.8. It's 0.809 and some stuff is equal to x. Now, I wrote that on there so you can see what's going to happen. I'm going to round this to 2 decimal places because I'm talking about money. So 24.81. And that's x. Is that my answer? Is that the answer to my question? Well, that's what x is. Is that what I was asked to find in this problem?
No.
No, it's not. So how do I answer the question? Remember?
You have to find the amount of sales tax collected.
Exactly. So the sales tax is actually 0.05 times x. Sometimes our x is not the actual value we're looking for, but we have to label it as such so that we can find the actual value. So this is the original amount of the receipt. So this is the amount of the receipts that this person collected at the end of the day. The sales tax is what we're looking for. So our sales tax is actually 0.05 times 24.81. And so we'll multiply that. Part of the reason I'm telling you this is because I want you to be super careful. If this was a multiple choice question, sometimes the answers are not reasonable. So if you see 24.24 as the amount of sales tax, I hope you realize that that is certainly not going to be how much sales tax was collected. So anyway, so if I multiply that together, I get 121 and then 24. It's 24.05, but again, I want to round this to 2 decimal places because it's money. And since the third place is a 0, I don't change this. And so this is my amount of taxes. Okay. I rounded this one up because this number past the 0 was larger than 5, so it rounded up to 1. But on this one, I did not. So okay. This is a very relevant problem. It's kind of a real world type of problem, but sometimes we have to think through these. The other thing I can tell you about application problems is sometimes there are legitimate, legal, ethical ways to solve a problem that maybe are a little bit more convoluted than writing an algebra equation. So the nice thing is sometimes you can just, some of you guys, you just have minds that think in terms of things like this. And so sometimes you've learned other ways to do it. And so that's perfectly fine. If you can solve it without writing an algebraic equation, you know, I'm not going to take points off if your equation looks a little bit different than mine. So like I said, sometimes with application problems, there's more than one way to do it. Okay. All right. Okay, so we're going to talk about percent of increase. I wanted to throw some just percent problems in here because I think that these are important. Because I think they're kind of just more real world types of problems than sometimes we get with application problems in algebra. So the scores on the college entrance exam rose from 20.5 in 1976 to 20.8 in 1987. The question is, what is the percent of increase, or what percent of increase is this? So in order to find percent increase, you first have to find amount of increase, okay? So to find, I'm going to make a note here, to find percent increase, you first find the amount of increase. So we have to find the amount of increase. And so the first thing I have to do then is I have to find the difference in these two numbers. So the amount of increase, and this is one of these that we're not going to try to really write an equation. I really want you to think through this. So the amount of increase means that I take the amount it increased to and I subtract what it started with. And so put that in your calculator, do it by hand, it doesn't matter to me. But the increase is an increase of 0.3. We're not rounding that, we're leaving it right there. In order to find the percent increase, I'm going to take the amount of increase and divide it by the original, okay? So this is kind of a formula. So the percent of increase is the amount of increase, and you might want to write this down, divided by the original amount. Okay? Not what it increased to, but my original amount. And so my percent of increase is going to be my decimal of 3/10 divided by my original amount, which is 20.5. Okay? So you can always use this formula. This would work for percent of increase or percent of decrease. If you want to do percent of decrease, it would be the amount of decrease divided by your original amount. So in other words, if it had gone from 20.8 to 20.5, you would have that decrease of 0.3%, and you would be dividing it by the original amount, okay? And so again, we're going to punch this into the calculator because I don't do decimals in my head. And this is going to turn out to be, and watch what happens here. I'm going to write several decimal places out here, and it just keeps going. But because I want a percent, I'm getting a decimal here. So I'm going to move my decimal 2 places. I'm multiplying by 100. So the percent of increase is 1.46%. And I am going to go to 2 decimal places. So you're going to take this and multiply it by 100. So the percent of increase is 1.46%. Okay, so just some manipulations with percents and decimals, because again, I just think that that's kind of practical information that sometimes we neglect to talk about in algebra. So probably more relevant to the real world than anything else. Okay, we got 2 more problems. These are my favorites. Oh yeah. These are what I call mixture problems. Love some mixture problems. Okay, so I am, disclaimer, I can't draw. I have a great appreciation for people who can, but it is not me. So if you are one of those people who can draw, please don't laugh at my pictures because my pictures are terrible. So, but I'm going to draw you some pictures up here because I am a very visual person when it comes to solving these kinds of problems. And we're going to talk about why these are mixture problems and how to be very consistent with solving them. If you've learned to solve these with a box, the box is great, and I have no problem with the box. I use containers because we're literally mixing these. So why do I know this is a mixture problem? Let's read the problem. A chemist must mix 8 liters of a 40% acid solution with some of a 70% solution to get a 50% solution. How much of the 70% solution should be used? Okay, so that's actually what I'm looking for. So it's kind of easy here to first of all identify the how much. But first I want you to look at why this is a mixture problem. Do you see this word mix? That makes it a mixture problem. We are mixing things together. So it's kind of like I have my coffee cup and I have my water thing, and I can pour one thing into the other and I get a new container. And that's what I'm going to have. So I'm going to mix these things together, and I'm going to show you how to do that. So once again, I'm going to identify the how much is the 70%. So X is going to represent the amount of the 70% solution. And we're going to talk about some tricks as to how to do this. So when I do mixture problems, this is what my container, and this is where you can't laugh at me. This is what my container looks at. And I'm going to be very consistent with this, okay? I'm going to put the percent in the top, and I'm going to put the amount in the bottom. Always, 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 okay? And just like I did with my coffee cup and my water bottle cup, I'm going to take, here's my first one, and I'm going to do 3 of these. And I'm going to add it to my second container. And this is going to be equal to my mixture. So the third one over here that's over here by its side is always going to be my mixture. Always. Okay. Now these other two, it doesn't matter which one's which. But I have 1, 2, 3 percentages. I have 40, 50, 70. Okay. I'm going to show you 2 different ways to do this. One, you can just read the problem. Okay. And you can probably figure out which is the mixture percentage. But I'm going to tell you the easy way to do this. Take those 3 percentages, 40, 70, and 50, and put them in numeric order. Okay, so if I said put 40, 50, or 40, 70, and 50 in order, which one of those numbers would be in the middle of those numbers? I'm literally asking. If I put those 3 numbers, 40, 70, and 50 in order, which one would be in the middle? $50. Excellent. Thank you very much. So 50 is my mixture percentage. It always works. Always will work. Your middle percentage when you put them in order is the percentage for your mixture. Okay? It's lovely like that. Okay? So now, and notice that my percent's in the top. So now I'm going to go and I'm going to put the other 2 percentages in here. Here's 40, here's 70. Why am I choosing? I don't know. I just am. They're in that order. I'm just putting them in that order. You could put 70 and 40. It doesn't matter. Here's what matters. I have an amount, 8 liters. Does 8 liters go with 40, 70, or 50? Somebody read the problem and figure out, does 8 liters go with 40, 70, or 50? I think some of y'all gone to sleep on me.
40.
It goes with 40. Thank you. 8 liters of a 40% solution. So here's my 8. I already said X was 70. Okay. So if I took 8 and added it to X, I would get a total amount for my mixture of X plus 8. And if you can get this, you can solve the equation, because now I can write my equation. I am always going to write my equation by multiplying top times bottom. So if I take the top of this equation or top of this container and multiply it by the bottom, I'm going to have 40 times 8 plus 70 times X is equal to 50 times X plus 8. And now I have an equation that you can solve. And it will work like this every single time. I can change these percentages to money amounts if I happen to be talking about a mixture that involves money amounts. And I can change that money amount and it can go in the percent place. So price percent can be interchangeable. Okay. This is the one kind of problem where I don't have to change my percent to a decimal. So it makes it really nice. And the reason is because all three of my containers have a percent. And so I can just drop that decimal. And so now I have an equation. And in order to solve the equation, I simplify before I solve. So 40 times 8 is going to give me 320 plus 70x. Make sure you simplify the right-hand side too. So I have 50x plus 400. I'm going to subtract 320 from both sides to be able to solve this. So 320 on both sides leaves me with a 70x is equal to 50x plus 80. If I subtract 50x from both sides, then I'm going to get 20x is equal to 80, and x will be equal to 4. And it takes 4 liters of a 70% solution to get what I want. Questions? I know you get the questions when you start working them on your own and somebody changes something in it and you're like, I don't know how this is. That's okay. That's when you send me emails or you ask me questions. Okay. All right. Excellent. We got one more of these. And then we're going to go look at Miles Plus. Okay. So this is a little bit of a tricky one. Because this one, well, it's just a little bit different. Okay, so how many liters of a pure isooctane fuel, I don't know what isooctane fuel is, but that's beside the point, should be mixed with 200 liters of a 94% isooctane fuel to get a mixture that is 98% isooctane? My point being is you don't even have to understand what these problems are because I have no idea what that is, but you can still do the math, okay? It is a mixture problem because I am mixing things, mixture right here. Okay, so I have 2 containers that I'm adding together. This is my big thing. 1 container plus another container is equal to a third container. Okay, I am trying to find out how many liters of pure isooctane. Okay, so I'm going to let X be equal to pure isooctane stuff. Okay. I only see 2 percentages here. I see 94% and 98%. I need a third percent. I got 3 containers. Anybody want to help me out? I know I've got a third percent up here somewhere. Anybody know what that third percent is?
100%.
Exactly. What is 100%? Which one is going to be the 100%?
The pure one.
Exactly. So this is my 100% amount. Okay. And sometimes we miss that in the problem. So please make sure that you read this very carefully. So if I were to once again put these numbers in numeric order, which one of these 3% is going to represent my middle number or my mixture? So what percent is going to go here in my mixture? Somebody help me out. I'm waiting for Nico to put it in the chat down here for me.
98.
98, exactly. Okay. So 98 is my mixture. So over here, I'm going to have 100 is one of my values and 94 is my other one. So again, I don't have to worry about the decimals because they're all percents. Because X is representing my 100%, I'm going to put my X here. So that's my amount. Remember, it's percent and amount, right? So I'm mixing with 200 liters of this 94%. So 200 liters goes with my 94%. So I'm going to put 200 here. And that means when I put it all together, I have X plus 200. Okay. Occasionally, you'll be given the amount for the mixture, so just be really careful and read the questions, okay? Reading the questions is very important. And so now we're going to create our equation. And so we have 100x, so top times bottom, plus top times bottom, so 94 times 200. And that's going to be equal to top times bottom, so 98 times x plus 200, right? And now we have our equation, and we can simplify it, and we can solve it. So on the left-hand side, we have 100x plus, okay, so I can't do these big numbers in my head either, so 4 times 18,800 is equal to 94x plus 19,600. I can't talk even. Real quick, while you're solving this, and I'm going to solve it here in just a second, if you were to accidentally end up with a negative number for these problems, I hope you know that that's not possible. These are like real life problems, and you're not going to be mixing negative numbers of liters with something to get anything else. So sometimes we can find careless mistakes we make by looking at that kind of thing. So anyway, so we're going to subtract 18,800 from both sides. And that's going to give us 100x over here is equal to 98x plus 800. And then I'm going to subtract 98 from both sides. The hardest part of application problems is actually getting the equations set up. Most of the time, once we get to that point, you guys are good. And we're going to divide both sides by 2. And I get x is equal to 400 liters. And that's reasonable. So I need 400 liters of pure iso-octane fuel. Yay! Questions, questions, questions. Okay, so what I am going to do is